That's right. All right, so we're on page 37. All right, so what we're going to do is take the stuff that you have learned about your p-value and take it one more step. Because remember, our ultimate goal is to be able to um, make a decision about somebody's claim. That's our ultimate goal. Make a decision about what somebody claims. All right, so let's review some. Well, remember that our alpha, which is drawn like that, is the size of your rejection region. It will also be told to you in word problems. It'll say it's the area of significance. Frequently, it may say your significance level is 0.05 or whatever. If they do not tell you another number, then it is defaulted. So if they don't give you an alpha, then it's automatically 0.05. Okay? So if they do not give you the size of your rejection region, it defaults to 0.05. All right. And we've talked about this before. Alpha is used to make a decision about the validity of your null hypothesis. You know, do you have the ability to reject your null hypothesis or not reject your null hypothesis? So here we go. Let's take a look at some pictures that we're going to draw. Again, we're going to kind of duplicate what we had done before because it doesn't hurt to have this done twice. So let's draw yourself two normal models. Okay, draw yourself two normal models. Oh, you know what? I want to backtrack that, and I want to use black because I want to act like my black color is your pencil or your pen. And then I'll add colors, and I'll tell you when I switch colors, all right? Okay. So the first thing that we're going to take a look at is let's go ahead and draw a rejection region in there. So I'm going to draw, well, actually, you know, our null hypothesis is our claim, and that's right there in the center. Our null hypothesis is our claim, like if the M&M's company claims there's 20% blue M&M's. All right. So if the claim is true, where do all our samples fall? Around it. They're around it. They don't have to be all the exact same value because of sampling variability. Because you might get a different sample than I do. So remember, if the null hypothesis is true, all your samples are falling around it within reason. Some less, some more, and so on. Okay. All right, so let's go ahead and put our rejection region in there. What's that called, the rejection region? Nope. Alpha. Okay, let's put our alpha in there. So I'm changing colors. So I'm going to pick a color. I'm going to pick a red color. And I'm going to draw alpha. And I'm going to put it at 0.05 because that's the default size. So that means anything in this top 5% is in the rejection region. Okay, so I'm going to draw that on both of these curves. I'm duplicating it right here. 0.05. Alpha is 0.05. Okay. So there is the top. They're both the same. So I put an alpha of 0.05 on both of them. All right. So there's what I have so far. I have a colored rejection region of 0.05 on both of those curves. Yes, the alpha needs to go that direction because it's a Greek letter. If you don't make it go that way, it's like you putting one of your other letters, like in a P backwards, like, or a Y backwards, or a Z backwards. Yeah. So that alpha goes that way. That is a Greek letter, so the direction of it matters. Okay. All right. So now let's go put our sample that we get and then the p-value. What is the p-value? The p-value is the probability of getting our sample or something more extreme if the null is true. Okay, so very good. So on this top curve, I want you to put your sample that you get in the rejection region. I'm picking another color. So this is my third and final color. So I want you to put your sample right there. No, on just one of them. I'm only on the top one. Okay, so if that's the case, then I'm going to draw our p-value. So our p-value, so there's our p-value, is this blue shaded area. So the p-value is the probability of getting that sample or something more extreme if the null is true. So if all the data is around that curve. Okay. So first of all, where is that sample located as far as the rejection region goes? Is it in, or is this sample in or out of the rejection region? It is in. It's in the red area. Okay, so this sample, so we have our p hat is in the rejection region. Our sample, p hat, is in the rejection region. Okay? And I want you to compare the two colors blue of what I have up here, blue and red. My p-value is blue. My red area is the rejection region. Which is a bigger region? The red is a bigger region. So my p-value, I'm going to go back to my black. So in other words, you're saying that my p-value shading is smaller than my alpha shading. So that's key. What we've drawn here is that my p-value shading is less than the alpha shading. So the p-value is low. My sample is in the rejection region. So if your p-value is low, you will reject HO. So that's the key. Oh yeah, there's got to be a song for that. You know. So if the p-value is low, you will reject HO. So the decision made on this is reject HO. So in other words, we're saying to the M&M's company, hey look, I got this sample way out here. There's no way I would have gotten that sample if what you say is true and there are really 20% blue M&Ms coming off that assembly line. So I reject your claim. And I say it's actually much higher. Yes, you call them up and you get all sassy. That's right.
Okay, if I on the other side of the line, someone's getting all worked up over
blue M&Ms, that's right.
Nothing better to do with today.
True. Okay, so again, if the p-value is lower than alpha, you reject that HO. So if the p-value is low, reject that HO. Okay? All right, so we'll go over that shortly. Let's draw our sample here. Okay. All right, guys, we're on the lower picture. Shh, let's go. Focus back. We're on the lower picture, and I've got a sample here, and it's fairly close to my null hypothesis. It is only happening because of sampling variability. It is not outrageous. So let's color the p-value. So the p-value is the probability of getting this sample or something more extreme if the null is true. Okay, so our p hat is not in the what region? It is not in the rejection region. Oh, okay, we'll talk about that in a second. It is not in the rejection region. Now I want you to compare. You know, of course, we've got this blue shaded area is our p-value. And so I want us to compare the shading. So our p-value shading, How does it compare to the red, the alpha shading? It is greater than. So our p-value shading is bigger than our alpha shading. Now, we cannot say we accept the null hypothesis, and I'll go over why you can't do that shortly. So I cannot say, oh yeah, you're right, it is 0.2. I just do not have the evidence to reject it. So what we say is that I fail to reject it. So I don't reject it, so I fail to reject HO. Now I'm going to tell you, truthfully, whenever I first started teaching this course, I remember it was a summer and I was reading that textbook and learning this stuff, and it really just made me mad. I just like, this fail to reject phrase is just weird, and why am I using it, and why can't I not say accept the null hypothesis? So I'm going to tell you why. In fact, let's see. Let's go on to the next, because that's a big issue. Let's go to the next page, and if you look on the next page, down here, see up here's the top song that we are going to sing shortly. But I want to talk to you about, since it was brought up, why we can never say, never ever ever can you say the null hypothesis is true, or you never can say I accept the null hypothesis. So let's go through that. Draw yourself a picture, a null hypothesis, or a curve, sorry. In a court of law, this is O.J. Simpson, in a court of law, he goes into there and he is innocent until proven guilty. So write your null hypothesis as innocent. Okay? So you as a defense attorney, you collect data. You present it to the jury and then they will make a decision. Okay? Let's put a rejection region in here. Okay? Here we go. If I get a sample up here in the rejection region, I have enough data to reject his innocence. And if I reject his innocence, then what am I going to say that he is? Okay. So that's the deal. So if I get a sample right here, then I reject his innocence and I say, is it SE? I don't think that's right. CE. And say he is guilty. So if I have, see how it's in the upper part? If I have a lot of evidence, I can reject it and say that he is guilty. Okay? However, look right here. What if I have that amount of evidence? If I have this amount of evidence, what can I say about? Do I have enough evidence to reject his innocence? Okay. I fail. I am not able to reject his innocence. Does that mean that he is innocent? Do you hear me? This is huge. I did not have enough evidence. I failed to reject his innocence. And that does not mean he is innocent. I just didn't have enough evidence to say he's guilty. See, just because I failed to reject his innocence doesn't mean the null hypothesis is true. That's why you cannot say I accept the null hypothesis or the null hypothesis is true. You can never, ever, 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 ever say that. All right. So let's go on up here. We'll sing the song, and then we'll do this little thing here. So now, first, the words, you know, we can do this a couple different ways. We can say, because I certainly as an adult and a teacher should not condone that we are rejecting that hoe. But although that is definitely something that you guys tend to remember it wise. So, yeah, I mean, I'm sure your mom is telling you to do that, but, you know. So, I'll say reject HO, but you are welcome to reject that hoe. That's up to you, because that's more fun. That's okay. All right, so here we go. That's right. So now, let's take a look. And by the way, when I say that p-value is low, I am talking about that p-value being lower than what? Alpha, which is defaulted to 0.05 if they don't tell us, okay? So one more time, when I talk about p-value being low, I mean lower than alpha. All right, so let's go ahead and do the work here. We're going to compare the p-value, and we're going to make a decision. So number one, you got to know your decimals with this and be able to order your decimals. So here we go. P-value 0.067. Compare that to an alpha of 0.05. Okay, so you're going to put a greater than symbol right here. Okay. And what will our decision be? Okay, so you're going to write fail to reject HO. Okay. The next one, p-value is 0.02. How does that compare to an alpha of 0.05? It is low. So we will reject that hoe. Okay, will we reject HO? Do those other three real quick. Okay, one last thing before we go back and we put conclusions on the problems that we have already done. See, we go through, we understand what a p-value is, then we compare that p-value and make a decision. Okay, so we're going to talk about how important it is that we're going to put this thing into context. When we go back, we'll put it in context, meaning the actual things. Now, what I actually want to do is mention one thing first. So you can probably fit it down there at the bottom, but I'm going to make it larger. We will end up making two sentences. Okay, so I've got a little formula here. Well, in our conclusion will be made up of two sentences. Yes, I know you love writing. So, with our two sentences, sentence number one is about the null hypothesis. Sentence number two is about the alternative hypothesis. And so, here we go. Shh, 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 shh. So, our sentence number one says this. Since our p-value is, less than or greater than alpha, I reject. I'm sorry you don't have much room on there. I know I should have put this somewhere. Maybe up at the top of that page or at the bottom. Either top or the bottom. Sorry about that. Since the p-value is less than or greater than alpha, whichever it is, this is a generic statement, I reject or I will fail to reject HO. Okay, so that's what our first sentence will say. Since our p-value is lower than alpha, I would reject HO. If our p-value is greater than alpha, I would fail to reject HO. Okay, so that will always be our first conclusion sentence. Our second conclusion sentence is going to be if you have evidence or do not have evidence of the alternative. So you will say, I have evidence of HA, or I do not have evidence of HA. And we'll talk about which is which here in just a second. Okay? No, I don't have it. I've not made a conclusion sentence song. Okay? So I want you to think about this. Think about this real quick. Suppose I reject the null hypothesis. If I reject O.J. Simpson's innocence, then what can you say that I have evidence of? I mean, then I have evidence of the alternative. No, if I reject the null, then what am I saying about the alternative? Then I'm saying the alternative is true. If I reject the null, then I am saying I have evidence of the alternative. Okay, think about it this way. Say, OJ is innocent, is the null hypothesis. I mean, I'll just use this as an example. The alternative is OJ is guilty. Okay, so look here. If I reject the null hypothesis, then that means I have enough evidence to say that O.J. Simpson is guilty. Okay? What happens if I fail to reject? What happens if I fail to reject H.O.? Then I do not have enough evidence. Do not have evidence that he is guilty. Okay, so keep those in mind as we go through, and now we're going to go back and actually work on some problems we have already done and put the conclusions on them, okay? So let's go to your assignment that you've previously done, the Chapter 20, Part 1. In fact, maybe we'll just do... so turn, let's see what page this is. I believe, see if it's page 29. Will you check to see if this is Chapter 20, Homework, Part 1? Oh, Part 2. Part 2, you're right. Part 2. All right, very good. Yes, you have already done this, because we've already worked through defining p-value. Now we're going to make a decision and put a conclusion on it. See, there's room down there at the bottom. So here we go. What page was it, by the way? All right, page 29 in your text or your packet. So, okay, let's review this problem. This one was about autism. The nation said it was 6%, but we think that it may have increased. So, we did the work. Look at our p-value. We said there's a 0% chance of getting this sample. Hold on, let's see here. Let me pull this down. So we said there is a 0% chance of getting this sample or more autistic children if P is 6%. Okay, you have that already. Okay, so I want us to compare this p-value to alpha. Did they give us an alpha up top? No. Okay, no, they didn't. So if they did not give us an alpha, then what are we going to say our alpha is? Okay, so here we go. So let's say our p-value, which is 0, is less than alpha, which is 0.05. So that's what you write down. P-value equals 0. And 0 is less than alpha, which is 0.05. So there you go. Write it that way. Our p-value, which equals 0, is less than alpha, which equals 0.05. So think about that. We're saying then that the alpha is what compared to alpha? The p-value, sorry, the p-value is what? P-value is lower than alpha. Do you agree? 0 is lower than 0.05? So if our p-value is low, then what are we going to do? Reject HO. Okay? So since our p-value is low, we're going to reject HO. Okay, so then that's basically our first sentence. Since our p-value is less than 0.05, I reject HO. So think about it. I am rejecting HO. Do I have evidence or do I not have evidence that the autistic rate has increased? I do. So I do have evidence of this. Okay, so here we go then. We can finish this out and we can say there is evidence that the autism rate increased. Or you could say the autism rate is greater than 0.06. And that's finished. Conclusion. That makes a complete problem. There is evidence that the autism rate increased. So, since p-value is, which is 0, is less than alpha, 0.05, I reject the null hypothesis. There is evidence that autism rate increased. Or you could say is greater than 0.06. Okay, very good. Yes, the p-value is this percent. It's that probability of getting that sample or something more extreme. Okay, so let's do that again. Here we go. Next problem. Okay, this problem was about the customers. Oh, this guy, customer satisfaction, and he wants to reduce the rate of negative comments. Currently, it is at 8%, and he wants to reduce them. So the proportion of customer complaints, the negative comments. So let's take a look at what work we did. Our null hypothesis was that the proportion of complaints is 8% versus we want it to be less than 8%. All right, so coming down here, let's see what our p-value is. What do you have to say about that p-value right there? Okay, okay. So there was a 9.2% chance of getting that sample or something more extreme if the null is true. So we write this. We say p-value of, and I write it as a decimal, 0.092. And how does that compare to alpha? They didn't give me an alpha, so I'm going to say alpha is 0.05, and that 0.092 is greater than alpha 0.05. So our p-value is greater than alpha. So what's our decision then? We fail to reject HO. Okay, because it's not low. The p-value is not low. So I fail to reject HO. Okay, so since the p-value is greater than alpha, I fail to reject HO. Now I'm going to make a statement about the alternative. Okay, so let me let you think about this. Okay, I am not rejecting this. I'm putting a dotted line around this because just because I am not rejecting it doesn't mean it is true. I am not rejecting this. Does it mean it is true? Can you say the null hypothesis is true? No. I just what? Do not have evidence that the complaints are now less than 8%. I just do not have evidence of the alternative. Okay? So I was not able to reject this. It will stay in place. That doesn't necessarily mean it's that. It's just I didn't get enough evidence to reject it. So my second sentence would say, there is not evidence that the proportion of complaints went down, or you could say is less than 8%. Good. There is not evidence that the proportion of complaints has decreased. Okay, so I pretty much told everybody at the beginning of class to put those phones away, and they're back out. If I see it one more time, it is mine, and it is gone till you go to the office and you sign it out there. Which, even if you follow me down to the office after this class period, we're doing that. All right, let's go on to the next one. Okay, here we go. This was the proportion of regular season games won by the home team. The null hypothesis is that they were 50%. The alternative is that they were greater than 50%, okay? So I'm going to walk around, and I want to see you. Let's see, how many more of these do we have? 3, 4, 5, 6. Let me do one more with you, and then you'll do numbers 4, 5, and 6 on your own, okay? So here we go. Let's do one more. So we get a p-value of 0.0062. 0.62% chance of getting that sample or more wins if there is no home field advantage. So my p-value equals 0.0062. How does that compare to alpha of 0.05? Okay, that number is low. That p-value is low. Okay, so what's your decision? Wait. Yeah, so we are going to reject HO. That's our decision. So since the p-value is lower than alpha, I reject HO. Now we will make our sentence that has the evidence in it. Okay. So again, I rejected HO, so I have evidence that the proportion of home team wins is greater than 0.5. Okay. So there is evidence that the proportion of home team wins, of home game wins, home team wins, is greater than 50%. Okay, so in summary, before I let you guys do this on your own, today we talked about a couple of things. In summary, we talked about 0.5. Okay, so in summary, we talked about what, the alpha and p-value being low and such. Okay, if the p-value is low, what can you do? If the p-value is low, reject that hoe. If the p-value is low. Okay, thank you. All right. We talked about how you cannot say the null hypothesis is true or I accept the null. And then we talked about our conclusion. First sentence is about the null. Since the p-value is greater, I reject or fail to reject. And the second one, I have evidence or I do not have evidence of the alternative. All right, so I want you to now, as I walk around and watch you, do problems 4, 5, 6 from that homework, the little conclusion section. Do that now.